So in this video, I'd like you to calculate the integral, the indefinite integral of the sine of 4t multiplied by the sine of 5t. So have a go with pen and paper, and then afterwards you can come back and solutions and comments will follow. So I'll see you in a minute. Okay, welcome back. Let's look at the answer. So here is our integrand, and it's a product of two sine functions with different arguments, both linear in the variable that we're integrating with respect to, but with different numbers. Now, you could use integration by parts to calculate this integral. You're going to have to use parts twice, and there are going to be a fair number of numbers involved, and I think there's a possibility of making a mistake. It's easier, in my opinion, to recall a formula that involves two different signs being multiplied together. And that formula is the composite angle formula, that the cosine of a plus b is the cosine of a times the cosine of b minus the sine of a times the sine of b. So this is a generalization of the double angle formula, and in my personal opinion, I think it's good to know this formula off by heart, and also separately to know the formula for cos of 2a, the double angle formula, off by heart. Anyway, let's look at this formula. So this involves the sine of two variables multiplied together, sine of a times the sine of b, but it's also got the cosine of a times the cosine of b. And the way to get rid of this, and just to have that, is to use the even and odd properties of sine and cosine. So what we do is we look at this equation, and we're just going to rewrite it, and we're going to rewrite it as the cosine of a minus b. So if you think about it, a minus b means, so we're going to use a minus b is a plus minus b. So this equation here, this formula here, we can rewrite using this. It's just that everywhere where we had a b, we're going to replace it by minus b. So we have the cosine of a, that doesn't change, the cosine of minus b, and then minus the sine of a times the sine of minus b. So let's look at this formula. Here the cosine of a minus b is just what it is. Here we have the cosine of minus b, but we're going to recall that the cosine is even and the sine function is odd. And what that means is that the cosine of minus b, it's an even function, is the same as the cosine of b. So I can just immediately make this minus sign here into a plus sign and not change anything. And here, the sine function is odd. Sine of minus b is equal to minus sine of b. So what I do is I make this plus, but I have to take a minus sign outside, and there's already a minus sign there, so overall we get plus. So now we have got two equations, both involving sine a times sine b, both involving cos a times cos b, and you can see where you just add these equations, the cos a cos b terms would add and the sine a sine b terms would cancel. So instead, let's subtract them, because if we take this equation and then subtract this from it, then we're going to have this minus this, and minus minus will be plus, so these terms will add and the cosine terms will cancel if we subtract the equations. So it's helpful, I think, to give equations names if we're going to do this sort of thing. So let me call this equation 1 and this equation 2. And what we're going to do is we're going to subtract equation 1 from equation 2. So we now take equation 2 minus equation 1, and that's going to give us, well, on this side, it's cos of A minus B minus cos of A plus B. So we're going to get cos of A minus B minus cos of A plus B is equal to, and on this side, the cosines will cancel and the sines are going to double up because we have that minus minus this. So we're going to get 2 sine A sine B. So if we just swap the sides of the equations around and divide both sides by 2 to get rid of that, we obtain our key result, which is that sine of A times sine of B is 1/2, open brackets, because everything's divided by 2, cos of A minus B minus cos of A plus B, close brackets. Let's look at this equation. And if you think about it, this equation here is symmetric under the exchange of A and B. In other words, sine of A times sine of B is the same as sine of B times sine of A. So what happens if we swap A and B around on this side? Well, this term is easy. You get the cosine of B plus A, and that is the cosine of A plus B. It doesn't matter which order you add them in. Over here, you would have the cosine of B minus A, and that might for a split second look like a problem, but remember, the cosine function is even. The cosine of minus an angle is equal to the cosine of an angle. So cos of B minus A is the same as cos of A minus B. So this equation, this side, does have the symmetry you need here. Okay, so armed with this, we can calculate this integral. So let's do it. So therefore, the integral of the sine of 4t sine of 5t integrated with respect to t is going to be an integral, and then we've got a factor of 1/2 multiplying everything, so let's just pull it through the integral sign, make it look less scary, and then we have the cosine of, so a is 4t and b is 5t, so you're going to get the cosine of 4t minus 5t, that's minus t, but the cosine of minus t is the same as the cosine of t because it is an even function. So if you did put a minus sign there, the next thing you'd do is you would make it positive immediately. You really don't want to waste time trying to integrate cosine of minus t or differentiate sine of minus t. Use the even and odd properties. Okay, next term, minus the cosine, and now here we add the two arguments, 4t and 5t, so we're going to get the cosine of 9t integrated with respect to t. So this is going to be 1/2, open brackets, and the function that differentiates to cosine is sine of t. Differentiate sine of t, you get cos of t. And then it's going to be something like the sine of the same argument, 9 times t. And if you differentiate this, you'll get cos of 9t times the derivative of the argument, which is a factor of 9. We want a minus sign, and we don't want a factor of 9. So what we do is we just put minus 1/9 to mop up the factor of 9 when we differentiate. And thinking about it, if you differentiate that, you definitely get that. So this is correct. Plus an integration constant, and that is our result for this integral. Now, one of the things that I've tried to emphasize in this slide is using the idea that the cosine is even and the sine is odd. And that was why I deliberately chose to put the 5t second so that people are tempted to use that as b. So that you think, well, hang on, we get to cosine of minus t, but that is just cosine of t. And if you had a similar equation with sine of minus t, sine is odd, and you just say, well, that's minus sine of plus t. So I think that's a very useful thing. So to calculate integrals like this, which come up a lot, you need to remember this formula, the composite angle formula, and realize that you can rewrite it like this with a minus sign in front of one of the terms in the argument using the even and odd properties of cosine and sine. And with that, I'm going to give you one more exercise to look at yourselves. So finally, here is another exercise of a similar form, but now it's a sine times a cosine with different arguments. And what you should obtain is this result. Again, I would not recommend using integration by parts. And if you want a hint, I will give a hint in a moment, but I will just wait a second first for you to stop looking at the video and try it without the hint. Okay, if you would like the hint, the formula that you're looking for is a formula that involves sines multiplied by cosines, and that's going to be the formula for the sine of a plus b, and the sine of a plus b is sine a cos b plus cos a sine b. And in a similar way, using symmetry, you can look at the formula for sine of a minus b, and in that way what you will obtain, I'll let you go through it, is that the sine of a times the cosine of b is 1/2 brackets sine of a plus b plus sine a minus b. And again, you may very well find yourself using, in fact you will find yourself using, the even and odd properties of sine and cosine. Okay, so with that I'll stop this video.